All right, we're going to pick up right where we left off with this silver bromide problem because it's time for us to start talking about limiting reactants. Okay, so in the previous scenario, let me just rewrite our balanced equation for us. Okay, so we had 2 silver nitrate and we had calcium bromide. And then we had 2 silver bromide that precipitated because this is a precipitation reaction. And then we make some calcium nitrate, which is soluble. Okay, so in the previous problem, we started with 1.84 moles of silver nitrate, and we were told that it reacted, and then we had to figure out how much silver bromide we made, and that was the theoretical yield at least. But sometimes when we are doing a problem where we're given some information about reactants, we actually receive information about both reactants, or if there's more than 2 reactants, maybe we have all of the reactants we have some information about. So this might look like where we have 1.84 moles of silver nitrate, and we also find out that we have 0.846 moles of calcium bromide. So this is like a scenario. I like cooking, so I bring up a lot of cooking examples. So this might be an example where somebody says to you, okay, in the kitchen we've got lots of flour and sugar, and I want you to make some chocolate chip cookies. Here's 1 bag of chocolate chips, here's 1 pound of butter, and here's 1 dozen eggs. And so you look at that and they say, I want you to make as many cookies as you can. So you need to look at your recipe and find out, okay, well, how many cookies could I make? I have 12 eggs, but most cookie recipes only take maybe, 1 or 2 eggs, so I'm probably not going to run out of eggs. They told me I have lots of flour and sugar, so I don't need to worry about those. How about butter? Am I going to run out of butter first, or am I going to run out of chocolate chips first? And so you probably need to look at how much is in the chocolate chip container, how much is in the butter container, and that would be these 2 quantities that we're talking about right here. And then we look at our recipe and find out how much is needed of each of those things, and that would be our balanced equation. So what we need to do is now figure out how much of our product, these are like our chocolate chip cookies here, how much of our product we can make if we used up all the silver nitrate, and then to compare it to if we used up all of the calcium bromide. Now, in our previous video, we actually already calculated this. We calculated the grams. So we'll say, how many grams of AgBr can we make? So in our previous example, we had calculated that we could make a theoretical yield of 345 grams of silver bromide. So the question is, are we going to make, can we make 345 grams of silver bromide if we use up all of the calcium bromide? Or could we make more if we used up all the calcium bromide? Or could we make less if we use up all the calcium bromide? So what you need to do when you have a limiting reactant problem, and the key signs for a limiting reactant problem is that you will have information on multiple reactants. And that's how you know that you have a limiting reactant problem. And the way you solve this is exactly the same as what we just did. We just need to do more calculations. But they're the same calculations. So when we look at which calculations, we're doing exactly the same thing that we did before. We have our flow chart, grams to moles to moles to grams. we figure out where we are on the flow chart and where we need to be. So we have two A's. That's the difference. Okay? We have two A starting points. So in case 1, A is equal to silver nitrate, and we already solved that problem. B is equal to 345 grams of silver bromide. So we already did case 1. But in a limiting reagent problem, we always have to do it more than once. This time in case 2, our A is calcium bromide, and our B is still AgBr. Okay? So we're going to set up this problem. If we look at where we are, A is calcium bromide, because we're ready to go with case 2. We just already did case 1 in our previous video. We don't have to repeat it because we have this number. So this is case 1. So here's case 2. And here's your starting point A. You've got moles of A, so we're starting here. So I want you to pause the video and try going through your calculation all the way over here to grams of B, find out how much silver bromide you're going to get, and then I'll get back on and you'll unpause the video and we'll continue together and see what we get. Okay, welcome back. I hope you took time to do this because this is how you're going to get good at these problems. So our starting point with case 2 was 0.846 mole calcium bromide. And when we look at our process from this moles of A to moles of B, we're always using the balanced equation for this. And so in our balanced equation, we're relating calcium bromide to silver bromide. So we set up our units, and remember, just like we did in the previous video, we can see that we're going to start right here with moles, we're going to end right here with grams, and so we have 2 calculation steps. So our first one is this balanced equation, and we're going to put the numbers in there. And then our second one is going to be the molecular weight, and we're going to put that one in here. Okay, so for our balanced equation, we look at our units again. We're just going to start with our units. We put the units in the denominator that we want to get rid of, and we put the units in the top that we want to get. That's B, which is silver bromide. So we're going always moles to moles. And now in our next step, we're using the molecular weight to go from moles to grams. So we put the moles in the denominator so we can get rid of them, and the grams in the numerator. Now we can put in the numbers. So for our balanced equation, 1 mole of calcium bromide relates to 2 moles of silver bromide. Now we know that our molecular weight is always per 1 mole, so we can put that in. And then hopefully you already calculated it. So when you calculate it, the moles for silver bromide are the same as they were before, which was 187.77 grams. So we double check our units. Moles of calcium bromide cancels out. Moles of silver bromide cancels out. So our units are in grams of silver bromide, which is what we want so that we can compare it to our case 1 result. So when you do your math now, we're just putting this into our calculator. 0.846 multiplied by 2 divided by 1, which doesn't change it, times 187.77 divided by 1 again. And so the answer that I get here is 318 grams of silver bromide. So let's check back in. I'm going to rewrite these. So with case 1, that was 1.84 moles of silver nitrate as our starting place. We got 345 grams of silver bromide. And in case 2, when we started with 0.846 moles of calcium bromide, we got 318 grams of AgBr. Okay, so which of these numbers is smaller? Not rocket science, right? This is the smaller number. But now we have to reconnect with what the problem was asking us. The problem was asking us how much silver bromide we can make. How many grams of silver bromide can we make? So can we make 345? Can we make 318? Do we add these together? What do we do? So let's go back to our kitchen example. Let's say that in our kitchen example, each recipe used half a bag of chocolate chips and it used 1 stick of butter. Maybe I better draw a picture. So we had 1 bag of chocolate chips and we have 1 pound of butter, which has 4 sticks in it. So we say that each recipe takes 1/2 of a bag of chocolate chips and it takes 1 stick of butter. So if I have 1 bag of chocolate chips and 4 sticks of butter, you can see that in my first batch, I use half my chocolate chips and 1/4 of my butter. And in my second batch, I use up the other half the chocolate chips and 1 more quarter of my butter. So I can make 2 batches of chocolate chips because now I'm all out of chocolate chips. Excuse me, I can make 2 batches of cookies. But now I can't make any more chocolate chip cookies because I'm all out of chocolate chips. So with this real situation here, we look at whichever number is smaller, and this is our answer. I can't make 4 batches of chocolate or 4 batches of cookies and 2 batches of cookies. Even though I have 2 more sticks of butter, I don't have any more chocolate chips because I can't make any more chocolate chip cookies. So when we use up all of the calcium bromide, we're done. We can't make this reaction go anymore. So when we do a limiting reactant problem, we're going to set this up exactly the same way we always want to have, okay? We need a balanced equation. We need to think about our flow chart. Grams of A, moles of A, moles of B, grams of B. So I want you to have these every single time. Then we probably have reactant A, or excuse me, I'll say reactant 1 and reactant 2. And if we have reactant 3 and 4, just do this again, okay? With reactant 1, this is going to be A. This is also going to be A. We keep these guys separate. So whether we start with grams or with moles, we start our calculation process and we go over to B however far it asks us to go. So we're going to figure out the amount of B using reactant 1. Then we're going to take reactant 2 and we're going to do it again. Exactly the same calculation, but the numbers are different because we now have a different probably amount of this reactant. It may have a different stoichiometry in our balanced equation. So we calculate the amount of B both times. This was my case 1. This was my case 2. Then we see which is smaller. The smaller number is our answer. Because whichever one we ran out of first, so the reactant we run out of first is called the limiting reactant. Okay, so let's try another example problem for you to get a little more practice. So here's going to be our balanced equation. We have 6 moles of HNO3, which is aqueous. This is called nitric acid. And we're going to react it with metal. I decided on nickel, which would be a solid. And when metals and acids react, they often make hydrogen gas. And that's what's happening here. We're going to make some nickel nitrate. And we're going to make some hydrogen gas. And if you want a little extra practice here, think about what the charge is on the nickel ion, and think about what the charge is on the nitrate ion, and then therefore what the charge is on that hydrogen ion. So you can just write those down on the side for some extra practice and review on some of the other stuff we've been doing. And of course you can also take time to think about what's an ionic compound and what's not. All right, so let's write our problem now. Our scenario is we have 6.31 moles of nickel and 14.96 moles of nitric acid. How many grams of H2 can we make? Okay, I want you to stop the video or pause the video, and I want you to try this problem. So if you need to, you can back up and review what we just did. But I encourage you to just try it based on your notes and see what you can get. See how you can do. So let's review the problem and the process right before you start. We've got our balanced equation. I want you to think about your flow chart. So identify your case 1, identify your case 2. Where are we on our flow chart and where are we going on our flow chart? Set those up, doing the same stoichiometry calculations, grams to moles, those kinds of things that we've been doing, and find the smaller number. So pause that video and then come back and I'll give you the answers. All right, welcome back. When we do these problems, if we start with 6.31 moles of nickel, then I'm not going to write out the steps for you, although you're welcome to ask me about them in class. We will get 19.1 grams of hydrogen gas. If we start with 14.96 moles of HNO3, then we will get 15.08 grams of hydrogen gas. So which one's the correct answer? It's the smaller one. It turns out that nitric acid is our limiting reactant or limiting reagent. Because we run out of it first, and so we can only make as much hydrogen gas as there is nitric acid. Okay, you've had an introduction now to some limiting reactant problems. I know a lot of students are worried about limiting reactant problems, but remember these are exactly the same kinds of problems that we've been doing already. And so this isn't a new kind of problem. We're just doing it twice. So all the skills that we've been building up so far, converting moles to moles in a balanced equation, calculating molecular weights, these are all the same skills. We're just using them in different ways. So if you do have any questions about them, I'm happy to talk about them and do more examples in class. And I can pretty much make up as many examples as you want.